today we are going to learn about cross validation, grid search CV and random forest. So random forest is an algorithm, but grid search CV and cross validation, these two concepts is common across all algorithms, and it's very much recommended that we use it. Okay, because there is some automation happening based on something that we used to think and give it so as to get the better stability and accuracy. So we are going to use grid search CV and cross validation, so that there is some process which is get automated. So we are going to look into that. But before that, if you have not watched previous videos like stats or the other algorithms like linear regression, logistic regression, and previously we did learn about what is the ensemble learning. So please go through all of them and then continue come to this video. So this is a complete playlist. I hope you are following a sequence. So let's get started with cross validation. Okay, so so let's understand our current scenario, then we go for the new scenario, which is cross validation, which is helping us. So we have like previously we have taken the similar kind of example. I have 1 2 3 like that till 10th. Okay, so I have 10 records or 10 samples. I'll stick with the record thing, and we have column 1, column 2, column 3, column 4 and the output. Okay, so since I have 10, and when I do test train split, I'm basically dividing my data into training part and the testing part, correct? 7 8 9 10. Okay, so basically this much is going to be my training part. Okay, and this much I am going to give it for testing, so to find the accuracy and to find all the other metrics. So this is what we generally do, right? So this is fine when we have huge amount of data. But what if, like huge in the sense 10,000 1 lakh, that much amount of record, but I have only 300 400 500 1000, then I cannot do training on that. I can do, but that will not be the correct prediction, is what I say. Okay, so then we have some techniques to improve the dataset or increase the dataset. After doing all those things, still I don't have enough records to train my model in the correct manner. Okay, so that I am satisfied that my model is going to be working in a proper manner. So in that case, what happens is we come across this technique called cross validation. Okay, so cross validation, what is cross validation? We will see, then we will see what is the types of cross validation. So in cross validation, what happens is, we'll take an example. So example, we have 100 records. Okay, so this 100 records, and the first method we have is the holdout method. So holdout method means what? Let me write this, hold out method. Okay, so holdout method means that whatever data I am having, just split them into training and testing. Use the training data for training, use the testing data for testing. So that is what we were doing so far. So this is nothing but our holdout method. Okay, now second method we have is k-fold cross validation. So in this, what will happen is, let's suppose our k value is, for your example, k value is 10. So basically we divide 100 into the set, we'll divide 100 into 10 sets. Okay, not 10 10 10 records, we'll divide 100 into 10 sets. Let's say we have 100 and okay, we'll have 111 records. Okay, so in that case, k is equal to 10 means each set will have, set 1 will have 11 records, set 2 will have 11 records, like that. Set 10 will have 11 records, and set 11 will, no, only 10 sets, right? So each set will have 10 records. And okay, so here you can see this was 111 records. Okay, let me write again, 111 records. So 10 into 11, 110. Okay, right? So what will happen is, when I say okay, train my model now, so what will it do is, it will take the first set as my training and set 2 to set 10 as testing. I mean set 1 as training and set 2 to set 10 as testing. So this is my first I can say first fold. In the second fold, okay, so in the second fold what will it do is set 1, set 2, set 3 till set 10. So this time it will take set 2 for testing purpose and remaining all for training purpose. Similarly, in the third time what will it do is it will take set 1, set 2, set 3 and so on till S10. So this time it will take S3 as my testing set. So that's how it divides the testing set and the training set within the data that we have given to it. So that is called k-fold cross validation. Now similarly we have one more method. So this was, I hope this is fine, k-fold cross validation. Okay, now if I say I have 111 records, okay, and my k value is also 111, that is I want the 111 records to be divided into 111 sets. It means what? That each set will have one record. One record will be taken as a testing and the remaining all will be taken as training. So that is like one record, not one set. So each set will have only one element, correct? So each set have only one element which we don't use it in general, but yeah, we have theoretically this concept. So this is known as leave one out cross validation, means keep one set one record aside and train our model on all the data, then keep the second element aside and train our model on all the data. So that is called cross validation. So basically I hope you got it, that a holdout method is what we were using so far, and it is fine when we have huge chunk of data. And the second thing is recommended to increase or to, you can say, teach the model in a proper way with the small set of data set. And third is a theoretical concept which is only for understanding sake. So let me write that as well. So third one is our leave one out cross validation. Okay, so yeah, that was all about cross validation. Next we will see what is our grid search CV. Okay, let me say this. Now you know what is CV. Okay, now we are going to see what is grid search CV. So basically before that you need to know what is hyperparameters. So as we have seen previously, that hyperparameters are something algorithm specific input that it requires, apart from common things like data. You don't give data that you don't have. Okay, so it's not related to algorithm, it's basically the content on which our algorithm is going to run. So when we run algorithm, right, we need to give certain parameters. If we don't give, it will take the default parameters. For example, when this decision tree we were building, right, so we didn't use the params, but there are parameters where we can say that what is the maximum split that we want, because for one decision there can be 4 as well. Okay, for one decision there can be 1. This is not possible because minimum 2 is there. So okay, so we can set parameters, we can use the parameters which says what is the minimum split, what is the maximum split, and if you remember that this part where suppose this is our curve and this is the minimum error that is possible, and we give learning rate. So if learning rate is more, it will go like this, like this, like this, like this, like this, and below this it cannot go. So it will consider this as a minimum error. But if we give less learning rate, then it will go like this. And finally when it goes here, it sees that it is high, so it comes backward and it says okay, this is the minimum point. So this we came across because of learning rate. Okay, now if learning rate is more or less, then it will be like overfitting. So like learning rate is alpha, so this is one hyperparameter, this is hyperparameter, this is hyperparameters. Okay, so if you talk about decision tree only, you will have nearly 10 to 12 hyperparameters. So when we are trying to see, okay, this will be good, this will be good, okay, this combination will be good, but as number of parameters are increasing, the best combination to get is getting more difficult again and again. Okay, so I hope you are understanding what we are trying to say. Okay, so here basically we have hyperparameters now I know what you understood about hyperparameters. Now if like we have more number of hyperparameters, so it becomes difficult for us to get the to properly set the value of hyperparameters so that our model is giving us the better accuracy or stability. Okay, so we cannot like it is becoming a much more difficult for us, because we are going to do some maths, we are going to do trial and error, and the time consumption is going to be too much. Okay, so therefore the rescue comes an algorithm called grid search CV. Okay, so grid search CV, we say that okay, so this is my list of parameters, say learning rate, and I want to vary this from 1 to 10 or 0 to 10. Okay, so with the step of 0.1, that is alpha will become 0, 0.1, 0.2, 0.3, anything you can take up to 0 to 10. And I can for example, when I'm using decision tree, I can say okay, maximum split can be minimum split can range from 3 2 to 4. Okay, and maximum split can range from 5 to 6, and the decision tree criteria can be Gini or entropy. So basically what I'm doing here is I'm giving the parameter name and I'm giving the possible values or the range. Okay, I hope this makes sense. So I'm giving the hyperparameter and the range that is like kind of okay for me, and I want to find the best combination out of this. Like minimum split should be in the range of 2 to 4, maximum split should be in the range of 5 to 6, and this criteria should be in the range of can be either Gini or can be either entropy. So there are other parameters for which I'll give the possible values which I think can be correct. Okay, now after I give it to the grid search CV, it will try to run our algorithm, or I mean our model, on all the possible combinations. Okay, there will be too many combinations, so it needs to make sure that if you have less RAM, it will go out of memory. If you have a bit more RAM, it will take much more time, and if you have more RAM, it will be done as it will be done quickly based on our RAM capacity. So basically what we are saying is this grid search CV is going to give us the best possible combination of hyperparameters. Okay, so that I can write here, best combination of hyperparams. Okay, so if we say we'll try to, so in the implementation part, what we are going to do is we are going to implement the random forest, which is okay, let's learn what is random forest, and then we are going to give some hyperparameters in random forest, and we'll see even with that our accuracy is not increasing. Then we give all the possible I think these params are good, so I give those params to grid search, and it will give me again the best possible combination. And after I use the best possible combination of hyperparams, then I can see that the accuracy is increasing. Okay, so let's move on to our random forest concept. So once that is done, we'll go to our implementation part, which is like the least time consuming of all. So for understanding the random forest concept, I hope you have gone to the previous videos where we were discussing about the decision tree. Okay, so decision tree is one tree. Now group of trees or the huge chunk of trees is what we call as forest. Okay, don't argue about garden and all. It's just an example. So that's how the random forest came into picture. So you can understand that here we are going to use multiple decision trees or multiple trees. Okay, so let's say our decision tree, we will call it as D1. Okay, so decision tree 1. Okay, now it is random forest is one of the ensemble techniques. Now ensemble techniques means what, that we are going to use multiple models to finally come to a conclusion and predict. So because it is a random forest technique, and we are going to use all our classifiers or models as our decision trees. Okay, so how this happens? So this concept will be very clear if you have gone to the decision trees, where we are talking about each one single decision tree, and then the ensemble technique, how the ensemble technique follows. So we can say when coming to random forest, it is simply like we are giving the data, and it is taking input based on one of the bagging techniques, and then we have like suppose 3 models, or let's say 4 models. Okay, so we have decision tree 1, decision tree 2, decision tree 3, decision tree 4. Okay, now out of this we are going to get the inputs at a common place, and as I have told previously, that if suppose this is a classification issue, it means the output that we are getting is the categories. So in that categories it will take, okay, who has got the more votes. Okay, so here basically we don't take even numbers, we take odd number of models. So let's say decision tree 4 is not there, either you take decision tree till 3 or take 5, 7, anything. Okay, so we don't know how many trees we need to take, right? So again, that is one of the hyperparameters. I hope as we are learning and seeing what are the new things, then you can easily correlate. Okay, so here I am saying 3, sometimes I am saying 5, so I don't know the best combination with all the other hyperparameters. So that is again one of the hyperparameters. Okay, so here what I'm saying is, if we have classification, then I'll see which class got the most vote. So this is saying class 1, this is saying class 2, this is saying class 1. So basically my conclusion is my output is class 1. Okay, now coming to regression. So here I am basically getting all the outputs, and finally I am finding the C1 plus C2 plus C3 by 3. So that is, I am finding the mean, and that is my conclusion. I hope this makes sense. Okay, so that was all about random forest. Now we'll get back to our implementation part. So yeah, first I'm getting all the files that I need. This is our classifier, this is the grid search CV, that is we are going to we are going to make use, and you know the standard scalar for normalization of feature columns, not the output. Okay, yeah, so we are using the same wine quality CSV file which we used when we were creating the decision tree. Okay, and no pre-processing is required because it is already done here. If we want to increase the like for the first go, we don't need any pre-processing and all. If you want to improve the stability and all, then you can go for the pre-processing, but here our agenda will be restricted to our random forest. Okay, so basically I'm taking all the input features in my X and the output features in my Y. I'm done. So here I'm using which kind of cross validation? If you can see, this is a holdout cross validation, where I am simply splitting my test data into training and testing, and so testing data will remain out until I am done with the learning. So that is holdout cross validation. So I am getting the instance of decision tree classifier, and I am simply fitting and getting the score. So here you can see it is 65%. Okay, so this is what decision tree classifier means, a single tree, correct? Now we will moving to the ensemble part of the decision tree, that is random forest classifier. Now if you have seen previous videos, I hope you know what is random tree, so that every time if I am what I can say, when I am preparing the document, I am getting a different accuracy. When I am showing you, you might get again different accuracy, because when I am splitting, the splitting of data can be like at a random place, right? So if I want to have that whenever I call a split, it should always do the split in a specific manner, or I can say when I'm preparing the document and even when I'm the presentation, I should get the same accuracy. Then I will say that random state means it is dividing in a specific format, or specific what I can say, first record, then third record, then fifth, then seventh. If it is following that pattern, whatever pattern you are following, you will follow the same pattern every time I use this. I want to execute this query for any specific topic. So whatever algorithm I was getting while I was preparing the document and while I am presenting, so I execute n number of times any day, I'll get the same accuracy. So because here we are basically controlling the randomness. Okay, so I hope that makes sense. Next, I'm using, after using decision tree classifier, I'm moving to random forest classifier. So here if you can see, I have not given the number of, okay, if you can see here, so we have decision tree 1 2 3, means the number of estimators is 3. Okay, that is one more hyperparameter. So here I have not given that, so it will take the default value, which is 1. So in that case, my random forest classifier will again become the decision tree classifier only. Okay, yeah. So after I fit and after I get predict, so it is 64.1. So here I have changed the state while executing, that's why I got 65 and not 64. Otherwise it will remain same, both will remain either 64 or both will remain 65. Now why I'm not executing now again, because I will show you in a minute. Okay, I can execute, no issues, but you will get in a moment, so best just to wait for a moment. So after executing random forest classifier with n is equal to 1 or n estimator equal to 1 means random forest will become a forest with one tree, which is nothing but decision tree. Okay, so that doesn't make sense. So next we go for mentioning n estimator. That is, I am saying, okay, now the number of states that I want is 10. Okay, so use 10 decision trees and then fit and score. Okay, so fit will train and score will get the accuracy. So you can see again I am getting 64.1. So why, I mean 64%. So why I am getting the same? Because even you go with a 10 or 20 or 30, it is not affecting this model. Okay, I am not able to create a model who's giving me better accuracy even with more number of trees. So what I can do, I can go with adding more parameters. Okay, so adding more parameters will help me. It's like not only the number of, I can say, let me show you this, not only the number of models that I want, if increased could give me better accuracy, but I need to say, okay, this is the criteria you should use which criteria, and what is the depth that I'm restricting. Like if I don't give the depth, you can go up to 1000 or 2000 depth as well. Okay, so if you have seen the decision tree, where it is, let me, just a minute, no, yeah, so here if you can see, the depth was like 1 2 3 4. Okay, here it is like 1 2 3. So here I am having 3 levels, here I am having 5 levels, so that is depth. So I can restrict the depth, I can restrict the split. So there are too many hyperparameters that we are going to see in future, I mean in a moment. So I am creating a dictionary, okay, where I am saying my estimators, like number of models can be 40, can be 50, can be 60, or can be 70. My criteria can be Gini or entropy. My max depth range should be this, like should be among this range. Minimum depth, max, so minimum max feature. So all these things I am mentioning in the grid pattern, and then I will call grid search CV. That is grid search cross validation. So it is going to do everything for me. Okay, and then it is going to give me the best combination of these parameters. I hope that makes sense. Okay, so how it's happening? Rand. Okay, so I'm giving the, what I can say, an instance of the model that I want to have this parameters check upon. So for that, what I'm doing, I'm simply creating a random forest classifier with no arguments. This random state is not specific to algorithm, so I'm basically creating an empty instance of a random forest classifier or whatever classifier I want to have a check upon. So I am passing the estimator to that, and my dictionary to parent grid. Okay, and CV, if you know the cross validation that we have seen just now. Okay, so it is basically fivefold, I can say, and these things is not required as of now. Okay, then I try to do the fit. Okay, now what is happening inside this is, on this random classifier, okay, it is trying to put all these parameters and going to get me the best combination. So that is happening now. If you can see, you can see the star mark over here. Okay, unlike 8 or 9, it is happening over here for the past I can say half an hour. Okay, so I don't wanted to like waste the time here, so I have executed it previously and I'm waiting for it to complete. So I'll pause it as of now, and once this is done, I'll resume it again and continue. So here basically we are going to get the best parameter combination of this parameter. So after that, we are going to use that parameters in our classifier and we are going to predict. So I am pausing for now. Once this is done, I'll resume. Okay, so now grid search CV is executed, and finally you can see it is it took me nearly 65 minutes. So I have 16 GB of RAM and it took me 65 minutes. So what you can do is, like, you can use 2 params and then you can try to get the accuracy based on that. Again, in the next time again you can run the grid search with the 60-70. So that's how you can divide, or you can minimize the range, or you can have one of the criteria removed. So that's how you are exponentially reducing the time it takes. Okay, providing that you are not forsaking any of the params on your accuracy. Okay, so finally I am getting all these parameters that it think that it is best suited, so I can print that by grid search dot best param. So Let me try to use this grid search dot tab. So if I click on tab, you can find all these parameters. Okay, it is like similarly how we try to read the documentation for the all the other functions and parameters and the documentations of parameters. Okay, so tab and shift to tab, either of them. Okay, let me remove this. Okay, so now finally I'm using creating one more instance, and based on this entropy, depth, I'm assigning all these values to my okay. So if shift to tab, you can see all these parameters, right? So if I don't give any criteria, by default it will consider Guinea as a criteria. So what are all the possible values of that criteria? I can okay, yeah, if I come to here, default is Guinea. Guinea is for impurity measurement, entropy is for information gain. So that's how I can like find all the documentation within the notebook itself. Now if I execute, I can see that it is 65%. So it the percentage increase is less, but okay, it did increased. Okay, yeah. So that's about our grid search, and finally I'm saving it so that I can use it for prediction. I can use it in my application. So if you don't know how to deploy and all, you can continue with the playlist. So that's all for today. If you have any queries with respect to the cross validation, types of cross validations, the random forest, and finally the grid search, so any queries with respect to this, please write down in the comment section. And if you liked my explanation, please share and subscribe. Okay, so that's it for today. Thank you.